So here we're going to use the distance formula to come up with the distance. Alright, so what we're going to do is say change, we're going to take the difference in our x's. So I'm going to say 3 minus negative 2 squared plus 4, well, negative 2 minus 4. Okay, so I just took them in order. So I did 3 minus negative 2, so that's going to become plus. Okay, and then we got negative 2 minus 4. Of course, that's squared. So d is equal to the square root of, we're going to add these two together, 5 squared plus 6. Technically, it's negative 6 squared. So we end up with 25 plus 36, and we're going to take the square root of that. Okay, and then we end up with d is equal to the square root of 61. So that's the distance between those 2 points using the distance formula. Okay, now you should work problems 1, 2, and 3. And then I want you to go ahead and do 4. Now what we'll do with 4 is we'll just use this as another example. So make sure you go back and you work 1, 2, and 3, but I'm going to go ahead and work 4 with you as our second example. Alright, so what we're going to do is we want to come up with the length of the line segment. Okay, and so what we need is the ordered pair. Now, as we did before, you could make a triangle out of it, but we're not going to. We're just going to find the ordered pair and use the distance formula for this. So to do that, what we'll do is we need to know what this is, and we need to know what this is. Alright, and so what we need to know for those points, so I come over, I go 1, 2, 3, 4, 5, 6. Okay, so we're at 6 in the x, and then down 2. So 6, negative 2 for that point. And then we'll do the same thing. So we'll come over. So 1, 2, 3, 4, 5. So we're at negative 5 in the x and down in the y. So 1, 2, 3, 4, 5. So negative 5, 5 for that. And so to find the distance, what we're going to do is take the change in x. So we're going to take negative 5 minus 6. And we're going to square that. I'm going to clean this up a little bit. Okay, so we're just using the distance formula. I just didn't write it out again. And it's going to be plus the change in y. So it's going to be negative 2 minus 5. And I'm going to square that. So I end up with distance is equal to negative minus a negative is going to be, we're not changing the signs, it's going to be negative 11. Then we have to square that. So I'm going to go ahead and write out negative 11 squared plus negative 7 squared. So we end up with 121 plus 49. Alright, and then we take the square root, add these together, and we get 170. We're going to go ahead and take the square root of that and leave it as 1 decimal place. So we end up with approximately 13.0. You should get some decimal answers out here, but we're going to leave that for now. Alright, looking at example 3 here, we want to find the perimeter. Now remember, perimeter is the distance around. If we walked from one point all the way around the rectangle back to that point. Alright, so now we could use the Pythagorean Theorem or the distance formula to figure out the distance between the points. So we really don't have to do that. We can just count. So that's what we're going to do. Alright, so for this one, I would count. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the distance there is 9. Now this is a rectangle, so the side across from it has to be 9 as well. And then I would count here. I'd go 1, 2, so that's 2, and that's 2. So perimeter, and we're just going to add these up. So it's going to be 2 plus 9 plus 2 plus 9. So the perimeter of this ends up being 4 and 3 is 13, and so we end up with perimeter being 22. Now we were told it was in centimeters, so it's 22 centimeters. Now, area for a rectangle or a square, well, for a square it would be side squared, but because they're the same, it's just length times width. So we take one of these, 9 times 2, so it'd be 9 times 2, which would be 18. Now it'd be centimeters squared, because area is always in squared units. So that's how we can use ordered pairs in a rectangle to come up with area and perimeter of a rectangle. Okay, and so what you would need to do here is now pause this, and I want you to do 7 and 8, finding the area and the perimeter for those rectangles. Alright, this is example 4. Where you have they're wanting us to find perimeter and area of this triangle. I'm going to approach it a little bit differently than it may be there. Now we can find the distance between C and B and A and B. Now by just counting. So we can go 1, 2, 3, 4, 5. Okay, so A is 5, and then we can count here, so we can go 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll say B is 9. Now the other thing we got to come up with is this distance before we can do perimeter. Now, perimeter, again, we're just going to add up the sides, and that's our perimeter. Alright, so to do that, we're going to use the Pythagorean Theorem again. So we know the two legs, so we can find the hypotenuse. So we'll take 5 squared plus 9 squared is equal to C squared. So we end up with 25 plus 81 is equal to C squared. Okay, so then when we add these two together, we get 106 is equal to C squared, and take the difference. And 106 is equal to C, which is approximately 10.3. So the distance between C and A, or the hypotenuse, whichever way you want to look at it, is 10.3. So to find the perimeter, we just add those up. So we'd add 9 plus 5 plus the 10.3. So we end up with the perimeter of 24.3. Now for area of a triangle, it's the base times the height, and then take half of it. So basically it'd be similar to a rectangle, but we're just taking half of it. Now this is a right triangle, so we don't, our height, is just this. So what we'll end up with is area is equal to 1/2 base times height. Okay, again, our base is going to be the 9, and our height would be the 5. Okay, so we would multiply 5 times 9 times that, and so then area in this case would be equal to 22.5 centimeters squared. I should have put centimeters here. Okay, again, because perimeter is a length or a distance, so it only has unit to the first power. Here, area would be squared units. Okay, so perimeter, again, is the distance around. We use the Pythagorean Theorem to come up with the hypotenuse distance, and then we just added all that up to come up with the perimeter.